All right, today we're looking at global variables, crafting interpreters in OCaml. Just a quick update of what I did yesterday. We started doing statements in state chapter, and I ran into some issues with the type system, but finally figured it all out. Let me pin this window again, keep forgetting to do that. All right. Now, I also did a little bit of a refactor after the stream ended. Not too much, but the main thing I did was I added a basic REPL and made it so that I could call a file. Let's give this a try here. Let's make this a little wider here. So if I um, pass a file name to do an exec OCaml then it will run the contents of that file. If I don't pass a file name, then it's going to put me in this REPL, and I can do something like 1 plus 2, and it'll print out 3. So just a really simple thing there with the REPL there, and technically, I guess it's not actually doing the printing part of REPL. REPL is supposed to be read, evaluate, print, and then loop. So the print is not happening because, so let's say I were to do just 1 plus 2. It doesn't actually print out the value of that. So if I want something printed, I actually have to put a print statement in there. And I can change that, but right now it's good enough for now. All right, so now we're going to pick up where we left off with global variables. So I think what I'm going to do now is I'm going to kind of read through the stuff that's interesting, but I'm going to skip over the implementation stuff because it's very different in how we're doing it in OCaml. And I may have to run it at any moment because I have to feed my 1-week-old daughter. So we'll see. Now that we have statements, we can start working on state. Before we get into all the complexity of lexical scoping, we'll start off with the easiest kind of variables, globals. We need 2 new constructs. A variable declaration statement brings a new variable into the world, var beverage equals espresso. This creates a new binding that associates a name, here beverage, with a value, here the string espresso. Once that's done, a variable expression accesses that binding. When the identifier beverage is used as an expression, it looks up the value bound to that name and returns it. Okay, just going to read the side note here. Global state gets a bad rap. Sure, lots of global states, especially mutable state, makes it hard to maintain large programs. It's good in software engineering to minimize how much you use. But when you're slapping together a simple programming language, or heck, even learning your first language, the flat simplicity of global variables helps. My first language was BASIC, and though I outgrew it eventually, it was nice that I didn't have to wrap my head around scoping rules before I could make a computer do fun stuff. All right, so we're going to start with global variables. Variable syntax. As before, we'll work through the implementation from front to back, starting with the syntax. Variable declarations are statements, but they are different from other statements, and we're going to split the statement grammar in 2 to handle them. That's because the grammar restricts where some kinds of statements are allowed. The clauses in control flow statements, think the then and else branches of an if statement, or the body of a while, are each a single statement, but that statement is not allowed to be one that declares a name. This is okay. But this is not. We could allow the latter, but it's confusing. What if the scope of that beverage variable? Does it persist after the if statement? If so, what is the value on days other than Monday? Does the variable exist at all on those days? Code like this is weird, so C, Java, and friends all disallow it. It's as if there are 2 levels of precedence for statements. Some places where a statement is allowed, like inside a block or at the top level, allow any kind of statement, including declarations. Others allow only the higher precedence statements that don't declare names. To accommodate the distinction, we'll add another rule for kinds of statements to declare names. To accommodate, okay, so program is now still, okay. So now program is a list of declarations. A declaration is either a var declaration or a statement. And a statement is either an expression statement or a print statement. Okay, so let's now make that change. Go to the parser, and we're going to need to modify the AST as well. So let's start with the parser grammar. Now we're going to have a program be a list of, let's see, what was it? Declaration. Declaration. Declaration is either a var declaration or a statement, and we haven't, oh, actually, that looks like it might be correct there. var declaration or a statement. Let's do that, or statement here. Okay. Now a program is any number of declarations, and let's just change the D to an S there. Okay. Or the other way around, S to a D. All right, let's check to see if Copilot did the right thing here. Var, then identifier, then express equal, and then expression, followed by a semicolon. Yep, that's correct. We don't have this thing called var declaration yet. I'm going to add that. And statement is what it was before. That hasn't changed. Okay. Now, let's see what we need to do. Okay, so to get this to work now, I'm gonna rename that to I. Okay. Now the AST needs to now change where a program is now, instead of a statement list, it's a declaration list. So we need a type of declaration, and it's either a var declaration of string and expression, or it's a statement. Okay, let's see if that's correct. Or it's just a statement. I think we can just say declaration is just a, no, I guess that's fine. And now this will be a declaration list. Okay. So I think that's the grammar there. Like most statements, okay, declaration statements go under the new declaration rule. Right now it's only variables, but later it will include functions and classes. Any place where declaration is allowed also allows non-declaring statements. So declaration rule falls through to statement. Obviously you can declare stuff at the top level of the script, so program routes to the new rule. The rule for declaring a variable looks like var declaration. Okay, like most statements, it starts with a leading keyword, in this case var. Then an identifier token for the name of the variable being declared, followed by an optional initializer expression. Finally, we put a bow on it with a semicolon. To access a variable, we define a new kind of primary expression. Primary. That's not a thing that we have here yet. True, false, or nil. Number or string. A grouping or an identifier. Is that the same as this expression here? These new grammar rules get their corresponding syntax trees. Over in the AST generator, we add a new statement node for variable declaration. It stores the name token, so we know that's what it's declaring along with the initializer expression. If there isn't an initializer, that field is null. Then we add an expression node for accessing a variable. It's simply a wrapper around the token for a variable name. That's it. As always, don't forget to run the AST generator script so you can update it. Okay. Parsing. And then we do the parsing stuff. Okay. Then we get into some environment stuff. All right, so I'm not entirely sure what the deal is with this primary here. It almost looks like the same definition of an expression. True, false, and nil. Numbers and strings, those are all literals. True, false, nil, number, string. Then we have a grouping and then an identifier. This is a grouping. I guess it doesn't have binop and yeah, okay. So I guess it just doesn't have binop and unop, but it adds identifier to expression. Okay. All right, well, I'm gonna take a break for now, and we'll pick up in part 2